Alright, welcome back everyone. This is the follow-up problem to the previous problem 13.36. We're working on 13.37. And as always, you could try to do this yourself. This is just the pathway that I showed in the previous practice problem, just for reference sake. You can try this yourself and then come back to watch me do it. So, like I said, I left this up because we can reference how we did the first practice problem to see if we can maybe adjust it in some small way to get a slightly different stereochemistry. And to really analyze this, I want to turn your attention to this part of the molecule, this specific carbon. Actually, this specific carbon, sorry. So it looks like after we do one nucleophilic attack with a cyano group, we turn a wedge into a dashed functional group. So after one nucleophilic attack, we just flip a wedge into a dash. And then the reason why we ended up with a wedge again is because we started with a wedge for this carbon. We did a nucleophilic attack, so adding PBr3 is a nucleophilic attack. And then we did another one. We did another SN2 and ended up with a wedge again. So it looks like, well, it makes intuitive sense. We start with one type, we turn it to the opposite type, and then we just flip it back. And that just requires two SN2 attacks. But when we only include one SN2, we flip a wedge into a dashed functional group, but we stay there. Our goal for this practice problem is to create two wedges, two wedge cyano groups. So maybe we could do kind of like what we did for this carbon. We performed two SN2 attacks. Maybe we could do the same thing for the bottom one. So perhaps there's a way to get the cyano group in two SN2 steps rather than one. And the way we do that, let me just erase this guy. The way we do that is, instead of attacking the epoxide with the cyano group in the get-go, we're going to attack it with a bromine and then attack the bromine with the cyano group subsequently. So for this practice problem, we're going to go from here to here using Br2. And this is just going to break the epoxide ring like before to create this molecule. Okay, and then see, after we do an SN2, we flip the stereochemistry. We're going to flip it back. We're going to flip it back with a cyano group. And then we're going to repeat this part of our first synthesis pathway for this top carbon. Just doing PBr3, flipping the stereochemistry, and then re-adding a cyano group, which flips the stereochemistry again to its original wedged form. And we could actually skip a step here. We did the addition of our cyano group in two different steps, but what we could have done is done PBr3, and this turns our alcohol into a bromine, and then gone ahead and continued with the cyano group. I just showed this because I'm pretty much showing like how, at first glance, if you look at, I'm pretty sure this is in your packet. If you look at the packet answers, these two different ways of getting the similar products look kind of different. But if you really look at it, we're just following the same flow, but adjusting one step. And that one step is just adding another SN2 so that we end up doing two SN2s instead of just one. So we return to our original stereochemistry.